Okay, grade 8. As promised, we're going to be moving on from radicals and going to be continuing to proceed into more algebra sorts of things with some equations and slope-intercept form and such. Today we're going to be focusing on something called the zero product property. Okay? Now, as an 8th grader, the key word there, product, should give you a heads up that this is going to be dealing with multiplication. And the fact that it's called zero product should give you a clue that the answer to our multiplication problems are going to equal 0. So let's look at a couple of examples to start. Let's just say, for example, that I have x plus 7, and I'm going to multiply that by x minus 10. Now, when I get one like this, it's pretty self-explanatory, and these are going to kind of be mental math. They're not all going to be mental math, but ones like this kind of will be. The first thing I'm going to think to myself is that x plus 7 has to equal 0. Well, if x plus 7 has to equal 0, and to isolate x, I'm going to subtract 7 from both sides, then that's pretty easily going to tell me that x is equal to negative 7. I think all of us understand that. Now, if I go to x minus 10, I also have to think that x minus 10 can equal 0. Because remember, what we're doing is we're multiplying. We have the value of whatever x plus 7 is, and we have the value of whatever x minus 10 is being multiplied together. And when they're being multiplied together, it's equaling 0, which means either the value of x plus 7 has to be 0, or the value of x minus 10 has to be 0. Because when you started learning your multiplication tables way back in 1st or 2nd grade, one of the first things that Mrs. Stevenson or Mrs. Wineland probably taught you is that anything times 0 equals 0. Okay? I'm sure they taught you that. And so one of these numbers, for the multiplication problem to equal 0, one of these values, either x minus 10 or x plus 7, also has to be 0. So if I do x plus 7 equals 0, then that means that x could be negative 7. But I also can get another value because it could be this number that equals 0. X minus 10 equals 0. To isolate x, I'm going to add 10 to both sides. And that's going to tell me that x equals 10. My final answer would be x equals negative 7 or 10. Either one. Let's look at one more. Similar like that. Let's go with, I don't know, let's go with y minus 2 over 7, y plus times y plus 8, all of that equaling 0. So once again, it's the idea that if the value of y minus 2 over 7 multiplied by the value of y plus 8 is going to equal 0, one of these two values has to be 0. Okay, technically they could both be 0 because 0 times 0 is 0, but as long as one of them is 0, the answer is going to be 0. So I'm going to think y minus 2 over 7 equals 0. To isolate y, I would have to add 2 over 7 to both sides. That tells me that y equals 2/7. But this one could also be 0. So I can also think that y plus 8 would equal 0. And in this situation, to isolate y, I would have to subtract 8 from both sides, which tells me that y equals negative 8, which means in my final answer, it means that y can equal 2 over 7, but it could also equal 8. Okay? Now, let's up the ante a little bit, because that, you're probably thinking, well, Mr. Swack, that's pretty easy. That's as easy or easier than what we were doing with radicals. Well, it can't all be that easy. All right? Let's say, for example, that I have 2x minus 14, and I'm going to multiply that by 3x plus 12. All right? And, of course, since we're doing zero product property, that's going to equal 0. This still isn't hard, folks. We still have two values. The value of whatever 2x minus 14 is, and the value of 3x plus 12.